Welcome to STEM NOLA. My name is Dr. Calvin Mackey, and I'm happy to have you all tuning in. As a little background, we founded STEM NOLA 7 years ago to expose and inspire and engage communities in science, technology, engineering, and mathematics. In the last 7 years, we've engaged over 50,000 K-12 students, over 12,000 families, and over 1,500 college students and STEM professionals. One thing that I'm proud to say is that we've put over $1 million in the hands of college students over the last 7 years serving as college interns with STEM NOLA, going out and engaging the community. So thank you for tuning in. Parents, thank you for believing in STEM NOLA and trusting us with your most prized possession, your child, your scholar. STEM NOLA believe that either we're training ourselves from the neck up or the neck down. In the 21st century, our children will only have one or three options. Either they're gonna take something, break something, and/or make something. And if we don't give them the skills and education to make something, like make a living, make a life, make a difference, it only leaves them to two options that we see on the news every night, and that's to take and break. I don't want that for my two children, and I know you don't want that for yours, and that's why we're here today to expose our children to the possibilities of the 21st century. This is my friend. This is Alpha. Alpha is a humanoid. A humanoid is a robot that tries to act like a human. This humanoid has 9 servos and can do pretty much anything physically that a human can do. This is our competitor in the 21st century. Alpha can actually do push-ups. Alpha can even show off. And Alpha can even dance. And like any superhero, Alpha has her own music. This is the machine. And the automatic machine in the 21st century will displace many workers. In the aftermath of COVID, you have to believe that there are many companies out there saying never again will we allow a pandemic or something that happened in nature shut us down. So COVID has exacerbated the possibilities of machines displacing people. If you're competing against Alpha, you will not win. The only way we defeat Alpha is by developing our heart and developing our head, training ourselves from the neck up such that we can control the robots so that the robots will not control us. That's why we're here. That's why STEM NOLA exists. That's why your parents want to make sure that you all participate in events like this so you can know the possibilities of the 21st century. Again, I'm Dr. Calvin Mackey, and I want to say thank you for tuning in. Now let's get busy innovating, creating, and making with STEM NOLA. Thank you.
All righty, thank you guys for joining us today. Before we get started, we want to give a quick shout out to our participants from last week, Ms. Javian Moore. Also, a quick shout out to our next participant, Ms. Kylie Gilboa. Thank you guys so much for submitting your pictures to webinar@stemnola.com. Great, so to get started with our biology live session today, we're gonna have our guest speaker, Ms. Natalie Salvar from Tulane Medical School.
All right, can everyone hear me? Oh, wait, I guess there's no response. Hello, everyone. This is a webinar, so I unfortunately cannot see you, and I did not come with a dancing robot, but I am so happy you are here today and that STEM NOLA has given me the opportunity to speak for a few minutes. A little background on myself. I am a first-year medical student, soon to be second year, at Tulane School of Medicine. Before attending Tulane, I studied at Colorado College, where I graduated with a major in neuroscience, minors in physics and chemistry, and a certificate in Asian studies, mostly from my semester abroad in Osaka, Japan. I know today's focus is biology, and I think biology is such a great science. As you can tell from my past studies, I enjoy a lot of different sciences, but biology is cool because it is the science of life. It allows us to best understand what is happening in our bodies, as well as the nature around us. However, when we first learn about biology in school, sometimes it can seem like everything is already discovered. This is not true at all. But I remember when I was in elementary school and middle school, and even into high school, being uncertain about what scientists did, because my classes focused on textbooks and not the creativity in lab. I was grateful in undergraduate to have opportunities to work in both a molecular biology lab as well as a biophysics lab. With the COVID pandemic, the need for continuous research in science has become even more clear. Without research scientists, we would not have a vaccine. However, the vaccine alone is not enough to help protect communities against the terrible virus caused by COVID. We also need doctors and nurses taking care of patients, teachers helping keep kids in school, and educated community members helping those around them understand the importance of social distancing and now getting vaccinated. I did not always know I wanted to study science and then go on to become a doctor. I would like to read my medical school personal statement to y'all to show how different experiences can lead to a career in STEM. So here it is. My dream was to be an actress. Through childhood and adolescence, the positive influence my performance could have on the nights of audience members made it fulfilling. On stage, I shared stories of marginalized groups such as Jews in Fiddler on the Roof, as well as connected with the broader theme of balancing progress and tradition. Tears as the casting on Atefka and hugs from audience members after a show symbolize the power of the performing arts. My grandmother taught me that learning was also powerful. She would say, learn everything about all, wherever, whenever, for as long as you can. My passions for performing and learning were complementary, as seen in my use of skills from the stage to memorize content for class, and my capacity to connect trends in societal development to themes in musicals. My sophomore year of high school, I realized that these passions work together, not only in the classroom, but also in the medical field. Similar to actors, doctors can push society forward. Rather than exposing inequities as performers do, doctors can recognize inequities and provide quality healthcare to people from all backgrounds. Doctors must understand how medical protocols benefit patients and treat patients as individuals, respecting their culture and autonomy. Recognizing this, I knew I wanted to be a physician, a career in which I could experience tears and hugs as I did when working on the stage, and make a difference that could last a lifetime or even save a life. I have committed myself to making my goal of becoming a doctor a reality. In doing this, I have continuously deepened my passion for this dream. I am able to connect everything I do to becoming a compassionate physician. This includes observing parallels between how I volunteer and how I went to practice medicine, and reflecting on my clinical experience from CNA school, which is nursing assistant school. Through volunteering with Lutheran Family Services, I have developed empathy and been exposed to the medical field in my role as a mentor for newly arrived refugees. Earlier this year with Lutheran Family Services, I helped a woman and her baby in an appointment with a pediatrician. The baby had diarrhea, and Dr. A suggested that she eat a diet of rice, toast, and bananas. The woman looked at me inquisitively when Dr. A said the word toast. I said bread, and she smiled, indicating she understood. I could not yet diagnose and treat disease, but I could see the mother's confusion and knew how to help. Recognizing a patient's positionality and communicating in a way that they can best understand is critical to positive health outcomes. Communication and understanding a patient's limitations can be difficult for physicians to focus on, given the many other demands they face. However, balancing competing demands is not unique to healthcare. I also experienced them as a mentor for refugees. Once I mentored a woman who progressed slower in English than my previous students, and I felt unsuccessful. However, when she would call her family, or when we would go to the store and she would introduce me as her American daughter and teacher, I knew I had evolved to be a reliable resource for her. Balancing quantitative gains with developing relationships is critical to success as a mentor and as a physician. Trust between a mentor and mentee leads to greater learning. Similarly, trust between a physician and a patient leads to better health outcomes. I observed the relationship between trust and health outcomes in my CNA clinicals. The first meal that I fed a patient during clinicals, she only ate a few bites. However, over the course of my 3 days, she began to eat more. On our last day, she finished her meal. Due to the severity of her Alzheimer's, her speech was limited and she did not fully remember who I was between days. However, she trusted the trust that she had developed in me somewhere in her brain was evident by her progressively more positive body language and improved appetite. In the same facility, I also saw how my cultural awareness could aid in gaining client trust. One woman in the facility was from Japan and spoke more Japanese than English. When I bent down, so I was physically lower than her, a sign of respect in Japan, and spoke in the formal form of Japanese, She looked comforted and was then willing to do exercises from the physical therapist that she had previously shown no interest in. There are many jobs through which people can serve humanity. With my passion for learning and empathy, I believe a career in medicine is where I can best serve. After medical school, I hope to open a practice in pediatrics or family medicine where I can develop long-term relationships with patients. From tutoring and mentoring kids, I have learned that I enjoy working with them because of their unique sense of humor and genuine honesty and curiosity that often gets lost in adulthood. I also hope to work for Doctors Without Borders and eventually transition into a policy role with the WHO. This would be similar to my progression as I had in volunteering with Lutheran Family Services. I started as a volunteer and moved to an administrative position to lead trainings and grow the volunteer program. I plan to practice pediatrics to help individual patients and then move into policy to make a larger scale impact in global health. All right, so now I want to share a quote from the outstanding Dr. Mae Jemison, who was the first Black woman to travel into space. She said, "Science provides an understanding of a universal experience, and arts provides a universal understanding of a personal experience." I want to encourage everyone here to actively engage in learning about science and also anything else that you are interested in learning about. Some key takeaways I hope you can get from my talk is that, 1, there is no such thing as a science person. Though we may learn at different speeds and struggle in certain classes, we can all study and engage in science. 2, there is so much we still need to learn about biology and other sciences. You can contribute to this by pursuing many different careers in science. And finally, even if you do not choose to continue in science, the skills you learn through activities with NOLA STEM and your classes are valuable. It is great for all of us to learn about what other people do and how they contribute to society so we can be more understanding and appreciative of one another. Everyone, have a lovely day, enjoy the activities, and best of luck in all that you do. Thank you very much to STEM NOLA for having me speak today. And I certainly want to get more involved as I'm new to New Orleans and learning about the different opportunities here. So thank you very much.
Mm-hmm. Absolutely, and thank you, Ms. Avar, and good luck to you in medical school. All right, we will bring on next our facilitator for the day, Ms. Capri Halton, who's a resident employee here with our administration team with a background in psychology and currently pursuing her master's in counseling, actually. Ms. Capri. Thank you, Chantel. Hi, you guys. My name is Capri Halton. I am an administrative specialist here at STEM NOLA. I will be your facilitator today. I have a bachelor's in psychology, and I am currently pursuing my master's in counseling. So let's get started. We're going to go over for our agenda, which is going to be some vocabulary terms, some objectives, some activity questions. Then we're going to get into our activities of our edible karyotype, lung in a bottle, finished off with some questions and answers. Let's start with some vocabulary terms. Chromosomes, a thread-like structure of nucleic acids and protein found in the nucleus of most living cells, carrying genetic information in the form of genes. Genes is the basic physical and functional unity of heredity. Genes are made up of DNA. Genes are such like different eye color that you and your mom may share, or different hair color that you and your dad may share. Karyotype is an individual's collection of chromosomes and is used to look for the abnormal numbers of a structure of chromosomes, such as sometimes doctors may look at this to see if people have different syndromes, like Down syndrome, could be used to search for your karyotypes. Respiratory system is a network of organs and tissues that help you breathe. It includes your airway, lungs, and blood. Our first question, so hopefully a poll question just popped up on your screen. It should say, how bones are in the human body? How many bones? How many genes are in the human body? 23, 206, or 3,000? Getting your answers. And it's okay. Do your best that you can on answering the question. So again, how many chromosomes are in the human body? Take a good guess. No right or wrong. So we're gonna take a few minutes. Get those answers in. Awesome. So a lot of you got a good guess on it, 23. You're doing good. Objectives. You'll understand the meaning, the terms chromosomes, genes, karyotype, and respiratory system, and apply them to the project correctly. You will create an edible karyotype and build a lung in a bottle. Another poll question should have popped up on your screen. So what are we experimenting with today? A, rockets, B, wind, C, biology. Take a few moments to get those answers in. Again, there's no right or wrong. Take a good guess. Awesome, you all got it right, biology. So we have a question of the day. You're gonna wanna remember this for later on once we're done with our activities. They read, what is a karyotype? How many pairs of chromosomes are in the normal karyotype? And what is the main muscle that we utilize in our chest when we breathe in air? Remember these for later. So let's get started with our first activity, edible karyotype. Materials. So materials you're gonna need, it's gonna be some sheet of paper, some icing, and of course, last but not least, gummy worms. What is the science behind our activity today, you may ask? A karyotype is an individual's collection of chromosomes. The term also refers to a laboratory technique that produces an image of an individual's chromosomes. The karyotype is used to look for abnormal numbers of a structure of chromosomes. So, like I said before, to see if Down syndrome sometimes. Karyotype is a picture of chromosomes taken through a microscope. The chromosomes are arranged from largest to smallest, and a cytogenist sorts through them for missing or extra pieces of chromosomes. This is a bonus. In total, there are 22 pair of chromosomes. The 23rd pair is an X and Y, which are the sex chromosomes. They relate for a female who have 2 X chromosomes, and males have 1 X and 1 Y chromosome. So let's get started. So I'm gonna move over to the overhead camera so you can see my workstation a little bit better. So what we're gonna do is we're gonna start off by numbering our sheets of paper. You may wanna take out 2 sheets of paper just because it may be better as far as workspace. As you can see also, I have some varying sizes of gummy worms. I have some that's already cut up for me. I have some medium size and some extra long gummy worms. In our instructions, you can eat our gummy worms. So if they're not fit into size, eat them. So right now, all I'm doing is I'm just numbering out the chromosomes that we're about to work with today. So I'm numbering from 1 to 23, okay? So make sure you're getting your numbers very spacious too, because you may need the work. Oh, hopefully you guys can count correctly. I just missed a number, but it's okay. It's okay. We're going good. All right. So I have my numbers spaced out. I am going to start replacing mine with a cheat sheet just so you guys can see a little bit better of the number and the arrangement of how I'm going to arrange our gummy worms on our sheet today. You guys should have some instructions, hopefully, that give you a cheat sheet as well on how to arrange your gummy worms. So here comes the fun part, assembling our gummy worms onto our sheet. So right now what I'm doing is I'm cutting off just a little bit of the tip of my icing pack so that I can use it to stick or glue in a way. Stick or glue my gummy worms down. All right, so let's start off with chromosome 1. So it seems like we have 2 large gummy worms to start off. Again, remember that our gummy worms are acting as our chromosomes. We also do another activity here as well as STEM NOLA called edible DNA, which break down a little further from chromosomes to DNA. So our chromosomes are made up of various DNA that are used to, say, our fingerprints, unique data and unique DNA that's individual to you and no one else. So right now I assembled my chromosome 2. So it seems like we have 2 giant gummy worms to show off for 1 and 2. Remember, we're doing it from largest to smallest. So we have to keep using our large gummy worms until we get down to our small ones. So for number 3, it seems like we have a large gummy worm and then a medium size. So I'm gonna take another varying size gummy worm. You do wanna make sure you're molding it right so it doesn't just seem like it's gummy worms on a paper now. So we have this one for number 3. I think that looks like a good number 3. So let's keep moving on to number 4. So number 4, we can see that there's starting to be a size difference. So I'm gonna take some icing and get my gummy worms together to start assembling my number 4. How are you guys' chromosomes coming out? Hopefully good. And remember, if you need to, bite it to size. This is an eating, engaging activity. So now for number 5 of our chromosomes, we have one straight one, that's a medium size, and then we also have another medium-sized gummy worm that we're gonna bend as well. And if you need more icing, please use more icing. Awesome, awesome, awesome. So let's move on to number 6. Number 6, it seems like we have a medium size and a large gummy worm again. So I'm gonna take one of the large ones. And there we go. And you're just gonna wanna keep on moving. So hopefully if you pass by me, you're doing awesome then. Y'all are ready to be biologists and study things. But if you're on the same one as me, number 7, that's fine too. We're just gonna take 2 medium size of our gummy worms and put them together. You're doing awesome. So now we're gonna move on to 8. And remember, if you're unsure how these are supposed to be positioned, use your instructions. It has a small cheat sheet for us to use. So my number 8 gummy worms seem to both be curved. So I'm gonna do my best to make sure they're both curved chromosomes. Now we're gonna keep going on to our number 9. And again, you may be asking, why is this so important for us to know? Again, this is what makes up various characteristics that are in our body. And this is another way that doctors can use their science in order to help us with today's health. So now we're on number 11 of our chromosomes. And this one seems to be in a nice squiggly shape. So do your best. And like I said, if you need more icing, use more icing. Can never go wrong with more icing. Let's move on to number 12. These seems that they're facing in opposite directions of each other. So I'm gonna place one gummy worm facing that way and another one facing the other way. How's you guys' sheets coming along?
I hope just as well as mine. Let's keep pushing on then. Let's go on to number 13. And as you see that we're going down our chart, our gummy worms are starting to get smaller and smaller and smaller. So now I'm gonna start off with some of my bite-sized gummy worms. If you don't have any bite-sized gummy worms, remember, we can eat them down to size. So go ahead and take a big chunk of your gummy worms so we can fit them to size. So let's keep going. We're on 15 now. Hopefully you guys are with me. Let me know how you're doing in the chat. Awesome. So let's keep going. We're on 16 now. These ones also seem to be facing in opposite directions. So what I'm going to do is just try to mold my gummy worms as best as I can to face in opposite directions. Now we're on to 17. And hopefully you guys are using some different colors so you guys can see the differences and how your chromosomes are pairing up with each other. If not, that's perfectly okay too. Now we're on 18. And our pieces are just getting smaller and smaller and smaller. So now we're on 19. We're almost to the end. 20. These gummy worms also have a little curve in it. So just make sure if you're able to bend them, do your best. Or use more icing. Now we're on 21. As you can see, 21, it kind of has a little curve and one is straight. So we're just gonna mimic our diagram with hopefully, let's do another one. One that's curved and one straight gummy worm. We're on 22 now. And do you guys remember what our 23rd chromosome represents, whether if you're gonna be a boy or a girl? Girls have 2 X's and guys have 1 X and 1 Y. So it looks like our sheet of karyotype represents or comes from a patient that's a boy. So we're gonna give him a medium-sized gummy worm and also bite-sized gummy worm. Awesome. And there you have it, you guys. Our karyotype made entirely of edible gummy worms. I hope you guys enjoyed this. Beautiful. Awesome. Awesome, awesome, awesome time, you guys. I hope you guys did a great job. I know you guys did a great job. So make sure you send pictures to webinar@stemnola.com, okay? We want to see those gummy worms and we want to see your karyotypes. So let's move on to our next activity. Let me clean up my space a little bit. So our next activity is going to be lung in a bottle. The materials you're going to need, it's going to be an empty bottle, scissors, 2 balloons, and tape. As you're gathering your materials, I'm going to read the science behind today's activity. Your lungs are an essential part of breathing. They take in clean air when you inhale and release toxic pollutants when you exhale. But lungs can do all the work on their own. They need a little help from our muscles when we breathe in air. We utilize a main muscle in our chest called the diaphragm. Air enters through the top, fills the balloon with air to fill the space. When you let go of the knot from the space no longer exists. So the air from the balloon is expelled, making it deflate. So let's get started with this activity. So for our first step, You're gonna take your scissors and cut off the bottom part of our empty water bottle, which is already done for us, so we don't have to do, which is awesome. Step 2, cut one of the balloons in half. So what I'm gonna do right now is I'm gonna cut off just a good amount of the top of our balloon. Don't wanna cut off too much. And if you need help, ask for help. If my balloon cuts. Hopefully you guys are having a better time at cutting your balloon than I am. Yes, please. I'm sorry, you guys. My scissors. Oh, quickly, I got some scissors on the side. Let's see. We're back and we're better. So let's try these scissors. Awesome. We got it now. Okay. So once you have the top of your balloon cut off, you can tie a knot at the end, and we're gonna set that balloon to the side, okay? So right now, all I'm doing is putting a knot right at the top of our balloon, okay? So now we can set this balloon off to the side. Next, we're gonna take another balloon that we haven't cut yet, and we're gonna place it at the inside or shimmy it down the neck of our bottle, okay? So try to shimmy, shimmy, shimmy our balloon in the neck of this bottle. So once you have that balloon shimmied in the neck of your bottle, you're gonna take the neck of the balloon and wrap it around the neck of the bottle. Just like so. Awesome. So once you have that neck of the balloon wrapped around, we're gonna come back to that balloon we just cut, all right? So I'm just gonna take a moment to repeat some of the steps that we did. So far, I've just cut off the top, a little bit of the top of my balloon. I've tied a knot in it as well at the base. I've taken another balloon of mine, shimmied it down our bottle, and just wrapped the neck of the balloon around the neck of the bottle, all right? So let's move on to our next step. You're gonna flip your bottle over just as such, and you're gonna take that balloon that we cut, and we're gonna place it right on top of our bottle, as so, okay? So this is how we should look right now. What I'm gonna do as well is I'm gonna take a few pieces of our tape that we have here and just wrap it around the sides of our balloon so that it doesn't come off when we're trying to do our activity later, do our demonstration. So just take a few pieces and securely secure that balloon on your bottle. All right. So once you have it secure, let's try this baby in action. So what you're gonna do is the balloon on the inside of our bottle represents our lungs. And then when you breathe air, you're gonna pull down our knot of the balloon. And when you blow out air, you're gonna let go of the knot, deflating the balloon inside, which is our lungs. So when we pull it down, you're breathing in, that balloon is getting nice and strong and filled with air. When we pull it out, our balloon deflates, showing that we're breathing out air. Try it for a spin. Let me know how it goes. Does your balloon work? Is it breathing in? Is it breathing out? Do we have a living lung bottle, you guys? Oh, the bottom also represents the diaphragm as well, you guys. So this red balloon that we're pulling down on and pulling up is our diaphragm. And this is how it works when you're breathing in air and breathing out air. Awesome. Awesome, awesome, awesome. So if you have fun with these activities like I did, I hope you guys send in some pictures at webinar@stemnola.com. I can't wait to see all the nice activities you created with me today, okay? So we're back to our question of the day. I hope you're ready. I hope you have some answers. Question 1. What is a karyotype? A, another way to use a phone. B, an individual's collection of chromosomes. Or C, something you can carry in your pocket. Take a few moments to answer. Let's see what you got. Get those answers in, get those answers in. Awesome, we all got it right. An individual's collection of chromosomes. You guys are paying attention. Let's move on to our next question. How many pair of chromosomes are in a normal karyotype? A, 2, B, 23, or C, 46? Let's see if you guys got this one. Get those answers in. Okay, I see y'all getting the answers in. And the answer is 23. We got it right. Y'all are awesome. Awesome rock stars. So last question of the day. Let's see if you remember. What is the main muscle that you utilize in our chest when we breathe in air? A, our lungs. B, our diaphragm. Or C, heart. Let's see. Let's see if you guys were paying attention. Of course you guys were, though. So let's get those answers in. Awesome. You guys all got it right. It's the diaphragm. You guys are paying attention. So I had a lot of fun with you guys today. Don't forget that if you have any amazing pictures, please send it in to webinar@stemnola.com. I can't wait to see them. All right? And then I'm going to hand it back over to Chantel, you guys. So I'll see you guys next time.
All right, you guys, thank you so much for joining us today. You can send your completed projects and email them us to webinar@stemnola.com. Our next session is scheduled next Thursday, May 27th at 4 p.m. Central, and we will see you guys next time. Thank you so much for joining us today. Oh, don't forget about our technology camps. If you are local, we have in-person camps right here in the office where you can engage with our STEM NOLA facilitators and volunteers and learn 5 different topics this month. So, and the DoD STEM camps, which are virtual. If you do not have the option to come in person, you can register anywhere in Louisiana. In Shreveport, Gulf Coast, New Orleans, and in the city of Alexandria, if you are in those areas. Definitely sign up for our virtual STEM camp. Thank you guys so much for joining us today. We'll see you next time.